Hello everyone, my name is Ali Nahvi and I'm a PhD student in construction engineering and management at Iowa State University. And in this tutorial, I'm going to show you how to build and analyze a structural beam using RISA 2D. You can find the link to download the version by Googling RISA 2D and then easily download the software. When you download the software and launch the program, you may start structural analysis by building the beam. The first step would be selecting the joint coordinates here. In order to create a joint coordinate, click on the box and the first joint will appear. If you want to add more joints, hit enter and another joint will appear. If you wish to delete a joint, just right click on the joint you want to delete and then select delete the current joint. For the demonstration purposes, we use a beam with two joints. The location of the first beam would be at point 0, 0, and for the second joint, I'm going to put 50 feet away from the initial joint. Once you come up with your joint coordinates, you may go ahead and close the joint window. The next step is to placing boundary conditions on our joint coordinates. So click on the boundary condition here on the data entry toolbar. Then click on the boundary condition window and the first joint would appear on the window. We want to see both joint boundary conditions, so hit enter and the next joint will appear automatically. In order to apply reaction in a specific direction, you're going to need to click inside the box here and click and hit R. Also, in order to get rid of the reaction, just click on the box and hit the backspace. In this beam, we are going to have reaction in both joints in the X direction. So again, on the X direction, we are going to have reaction on both joints at the X direction. And in the second joint, we want to see Y direction as well. Y direction as well. We click R again and the Y reaction appear under the Y tab here. So once this is done, you can go ahead and close the window. Now we have to add a member to connect our joints together and act as our beam. In order to do that, we need to select a member from the data entry toolbar here. Then when the member primary data window appear, just click on the window and the member information tabs would appear here. In order to see a member on the screen, you need to connect one joint to another. So we'll just switch this joint here from N1 to N2. Then, as you can see here, the member appear here. Now, since we created a member, we can start applying loads. There are three different types of loading that we can apply: joint load, point load, and distributed load. Joint loads can be applied on joint point loads, and distributed loads can be applied anywhere else. So in order to create a joint load, and click on the joint load on the data entry toolbar here. So and then click on the window and your very first joint will appear. This tab here named LDM will show that the joint load, what the joint load will do, whether to act as a load, displacement, or mass. So load, displacement, and mass. We have all of the options here. So for this example, we'll keep it as a load, and also the direction of the load, the direction tab will show that direction of the load, whether it's horizontal direction or it's in a vertical direction or it's a moment. Since we want vertical direction here, we choose Y. The quantity of the load should be chosen in this tab. The positive vertical direction is up and the negative vertical direction is down. So since we want to have a load, we want to load to point downward, we have to apply negative value in this tab. So I'm going to put minus 60 here. So when you're done with this, you may go ahead and close the window. Another loading system that we can have on our members is a point load. So click on the point load on the data entry toolbar, and then again, similar to the joint load, we need to click on the window and the point load options would appear here. So here, similar to the joint load, we have the member labor, direction, magnitude, and location. So similar to the joint load, I'm going to keep it in a y direction, and then for the magnitude, I'm going to select minus 25. And for the location, the current location of the point load would apply the load above this joint here. But we want to see the point load somewhere here on our element. So I'm going to change this to 25. And then you may go ahead and close the window. The last loading system that we can apply here in RISA 2D is distributed loads. So here, again, I have member labor, direction, and unlike the point load and joint load, I have start magnitude, end magnitude, start location, and end location. So as you know, distributed load applies a loading all the way across a certain location. So we are going to apply a start magnitude of minus 15 and end magnitude of minus 20. And also enter a starting location of 35 feet from the left joint and 55 feet from the second joint. And 50 feet from the second joint, sorry. So now we have all different types of loadings. So to display all of these loadings, we are going to press this button next to the BLC tab here. So once you hit this button, all your loading will show up. So we have the joint loads here, point load, and also a distributed load near to the second joint. So now we have all of the loads here. We may hide them or keep them. If you want to hide the load, you may click on this button one more time. But in this question, I'm going to keep these loads visible. So the next step, we are going to work on the load combinations. So click on the load combination section on the data entry toolbar and the window appears. Click on the window and all of these load combination and factors show up. So this is for giving certain loads certain degree of importance. For instance, if you have both live load and dead load combinations, live load has bigger multiplication factor rather than dead loads. But for our case, since we are just applying load and it doesn't matter, we can choose our BLC here, which is basic load case, and put factor of 1, which is the basic scenario, and here for the factor, again, enter 1. So all of our loads will be applied as they are, and we don't have any degree of importance here. So now, if you go to the joint loading tab here, You may see the in this tab the BLC one. If you want to switch it, you have to put another BLC here. So when we are done with this, we can go ahead and close the window. So the final step is to analyzing the beam. So for at this end, we need to click at this bottom here, and when this appears, we are asked to choose our load combination. So we only have one load combination here, and select it, and then we select the solve button. Okay, so since previously I worked with that, I'm asked that it delete my previous data. So if you work with this software for the first time, you won't see this. And here we have the results. We have joint reactions, joint deflections, and member forces like maximum and minimum shear, stuff like that. So as right now, this is just the beginning, and this is just a beginner tutorial for how to analyze a structural load with RISA 2D. And if you are interested, there are many tutorials out there in YouTube, and you can go ahead and search. And you may also want to design RISA with RISA 2D later with yourself, but for this course, this is it. This is what we want you to know about RISA 2D. Thank you very much, and have a good day.